Hello, my Math 7 QTs. Today we're going to start 5.5 and 5.6 notes, which is on simplifying algebraic expressions. But before we can actually start simplifying them, we kind of have to know and get this vocabulary down in order to actually simplify these expressions. So the first thing we need to know is an expression. So you've heard your teacher say expression a lot of times, but to actually put a definition to that word, it's going to be super duper helpful for this section. So it's a mathematical statement without an equal sign. So go ahead and write that in with me. So the opposite kind of an expression would be an equation. And just kind of a quick reminder of what an equation is. An equation has an equal sign. So they're like opposites. Just keep that in mind. I'm just kind of putting that up there. So therefore opposites, but we're going to talk lots and lots about expressions today. An example of an expression could be like the number 9, or another expression could be like W, or another expression could be like 8W. And then one more example of an expression could be like 7y minus 6. So those are all examples of expressions, but now we're going to move on to terms. So terms are each part of an expression that is separated by an addition or subtraction sign. All right, so right here, this is an example of a term. This 9, this is a one term. H is also one term, and 8W. Those are all one terms. I wrote it in purple for a reason. Okay, and then also this this expression 7y minus 6, this is actually a 2 term. Because like I said, the definition of a term is that it's separated by an addition or a subtraction sign. So therefore right here, this 7y is a term, and this 6 is a term. So that's why there are 2 terms in that expression right there. Okay, moving right along on our notes, we are now going to look at a constant. So a constant is a numeric term in an expression. So for instance, the constant, we're just going to look at this 7y minus x. We're going to continue looking at that expression. So the constant is the negative 6 in that above expression, that 7y minus 6. So a constant is, in a sense, just kind of the number. So the number all by itself. So therefore it's right here in that expression. Okay, and then moving again right along, a variable is a letter used, which we've now seen lots of variables this chapter and even before. So therefore, in our original expression, 7y minus 6, it is the y in that expression, 7y minus 6. Okay, and then the next one we're going to look at, so now we've seen constant. We know the constant is just the number. The variable is just the letter. And then the last part of this expression is the coefficient, which is a number, and I'm just going to abbreviate for notes since, a number multiplied with a variable. So like I said, that's the last part of the expression. So therefore, it is the 7 in that 7y minus 6 expression. All right, and then the last thing we're going to look at is like terms. And like terms, that definition will be terms that have the same variable or same variables raised to the same exponents. So for instance here, 5.6x and we could use like 7x. Notice that they both have that same variable x raised to the same power of just 1 if there's no variable there. But then if you have something that looks like over here like 2d and 2d to the third power, these are not like terms because this one is raised to the third power and this one is just raised to the first power. So even if this wasn't to the first power, even if it was like 2d squared and 2d to the third power, these would not be like terms because they have to be the exact same variable. So yes, they're both d, but they have to be raised to that same power. So it would have to be either both the number 2 or both the number 3. All right, let's move on to actually applying this vocabulary usage. All right, so now we're going to identify the parts of an algebraic expression. So like I said, this whole thing right here is an expression. And in this expression, we can identify how many terms there are based on how many plus and minus signs there are. So therefore, right here, I could automatically see that here's a term minus, here's another term plus, here's another term, and another. So you could be able to say, hey, there are 5 terms in this expression. But we're actually going to write the difference between a coefficient, a constant, and a term. So I know that if it's just a number all by its little lonesome over here, if I look back up in my vocabulary, I know that that is just a constant. And I know this is kind of a sad way to think of it, but I always think of like a constant loner, or it's all by itself. But that seems to resonate with me. So it's just constantly by itself, or a constant loner, meaning it's just that number all by itself. Another thing that we know is a coefficient. If you remind yourself back up at that coefficient, you can see that it's the number that's attached to the variable. So between these other two things that we're pointing out, we're either pointing at all of 4x or just the number 5 that's attached to the variable y. So I know that right here this is going to be the coefficient. If I can spell coefficient. But take a look, this coefficient is actually not just 5, but you also need to include that minus sign with it. Okay, so I know that earlier I was like, yeah, there's 5 terms, and I was just circling just the coefficients and the variables, but really this coefficient, the coefficient of that term, is actually -5, as in -5y is the entire term. And then the last one, we know that term must be this for x. And then for number 2, it says identify 2 pairs of like terms. So remind yourself what a like term is. It has to be the same exact variable with the same exponent. So I know that right here I see a 4x, and then I also see just a positive x. So I'm going to list that out as 4x and x because they both have that x variable. And then another pair of like terms, I see just one constant. That number 2 is all by itself. But then I see here a -9y and the -5y. So that's my other pair. So -9y and -5y. And again, notice that I've included that negative with that term, 9y, and the negative with the 5y as well. And then the last one, what is the coefficient of the third term? So let's go ahead and count our terms. This is term number 1. Here is 2. Okay, and here is 3. So I know that I'm currently looking at the plus x. So if ever there's a variable and there's no number attached to it or no coefficient, which we just learned that that's what that is, we can always just put in the number 1 right before it. So therefore, the coefficient of that third term is just the number 1. All right, let's go and turn over our notes. All right, so on this side, we are going to combine like terms. So again, like terms are terms that have the exact same variable. So we kind of did that on the front side, so this should be super duper quick. 10, if you remind yourself, is just a constant. It's a constant loner all by itself. But then I have plus 4y, and then I have a minus 6y. And I see that both of those have a y in it, so it's a positive 4y and a negative or minus 6y. So if you think back to those integers that we did, I know that I have a positive 4 and then I have a negative 6. So I know our negatives won the game and they won by 2. So therefore my final answer is 10 plus a negative 2y. But this is actually sort of silly to have both a plus and a negative right next to each other. So if you'd like to just drop that plus sign and have 10 minus 2y, absolutely. Why can't I combine these two things, and why can't I just say, oh, it's 10 minus 2, so therefore I have 8y? Well, we can't combine them because these are not like terms, because this one has a y, and then this term of 10 does not have a y. So this is actually just our final answer. And then kind of a little bit more advanced for you is to put this into standard form. And so standard form is where you always go from your highest exponent or your biggest exponent all the way down to no exponent at all. So even better would be to flip this around so that I have negative 2y. And then notice that this is just 10, which is the same thing as like a positive 10. So I know that I could write negative 2y plus 10, and this is going to be our final answer. But now, for now, you can always just leave this as well. But like I said, that is just in the green that I box in. That's just standard form. And here next year, and you are just going to have to be aware that your 8th grade teachers are going to want you to have that in standard form. All right, let's go ahead and move on to the next example. Number 2, I have 15a plus 6b minus a and then minus 6b. So the first thing I always look for is to make sure that every variable has a coefficient. So the first one, 15a plus 6b minus a. So because I just have that a, I know that that's the same thing as minus 1a. So I went ahead and just put that in there. And then I underline my like terms. So I know that 15a, I'm just going to underline all those a's with that purple color. So I see 15 a's and then a negative 1a. So when I combine those two things, a 15a and a negative 1, I know that I end up with just 14 a's. Okay, then I'm going to look at my b's. So a positive 6b and then a negative 6b. So if I have 6b's and then I'm taking 6b's away, it would have like plus 0 b's, right? We wouldn't have any b's left over. But there's no need for you to write that plus 0 b's. So our final answer here is just going to be 14 a's. And then go ahead and box it in. This is just us combining like terms. All right, and then our example number 3. This one's a little bit longer. So this one has a total of how many terms? Hopefully in your head you're kind of thinking, well, I see a 2m. There's one term, and then a 4mk, a 3, an 8mk, and a 2. So I see a total of 5 terms here. So I'm going to go ahead and make sure, yep, I have a coefficient for each term. Then I'm going to combine them. So I see an m. So I just have 2 m's. Then I look at all my other terms, and is there just any other terms that have just that variable m? And the answer is no. So therefore, m is just going to stay all by its little lonesome, 2 m's. Then I'm going to look at negative 4mk, and are there any other terms that have both m and k in them? Sure are, right over here. So negative 8mk. So notice that I'm attaching that negative or whatever sign it is that's before that term, because that's like a negative 4 and a negative 8. And all I'm doing here is just combining that coefficient, and nothing happens with our variables. Our variables just kind of stay the same. They're kind of like just like variables, or aka like denominators. So negative 4 and a negative 8 is going to give us a negative 12. And then, like I said, the m and the k just stay attached right there. It's just part of the term. And then the last thing we do is combine our constant. So I have a positive 3 and I have a positive 2. So 3 plus 2 is just a positive 5. Now, there's no specific standard form whenever you have all variables that are just an exponent of 1. So you can put it in alphabetical order. That's what I do in my OCD. You can just keep it like this. But I would always just have your constant as that last, very, very last term. So go ahead and box in your answer. All right, so next up is the 3 UTRI problems. I want you to go ahead and pause the video, work out 4, 5, and 6. And then once you're done, go ahead and push play to make sure that our final expressions match up. Go ahead and pause. Alrighty, so take a look at my answers and make sure that they match up. If they do not, I need you to go ahead and fix them. Don't just erase yours. Go ahead and like kind of cross through them. That way your teacher can see what it is that you had as your answer first. But then, yes, like I said, write this new answer down so that way we have matching answers for your notes. Okay, let's go ahead and look down at the next section. Alright, so now this one's very similar to the last above section, but now we're going to include that 5-1 material, that distributing. So we're going to, for number 7, go ahead and distribute first. Always, always, always distribute first, and then combine your like terms. So I'm going to distribute this 2 because it's directly outside of the parentheses. I'm going to distribute to the n, so 2 times n is 2n. And then I'm also going to distribute over here to this 5, or really it's kind of like a negative 5, or you can bring down that negative. It's totally up to you. But 2 times a negative 5 is going to give us a negative 10. And then I just bring everything else down. I didn't distribute here, I didn't distribute here, because those 2 items weren't in the parentheses. So now I'm going to combine my like terms. So I have a 2n right here, and then I have a positive 8n. So when I combine those two things, I get 10 n's. And then I'm going to look at my constant. So I have a negative 10, and a negative 2. Notice that both of those things are negative, so I'm going to add them together. I get 12 with a negative. I keep that sign, and then I cannot combine these two things because that first term has an n and that second one does not. All right, we're going to move over to the next example, example 8. So again, always, always, always distribute first. So if you see parentheses, look to see if there's a number directly out front, and in this case, there totally is. So it's a positive 4. Notice again that I've attached that sign with that number before I'm distributing, because I'm distributing a positive 4 to the 3. So a positive 4 times 3 is a positive 12, and notice I'm going to include this plus sign because when I bring down all my other terms, I'm still going to need a sign in between my two terms. So positive 4 times 3, and then I take the positive 4 over here, and I'm going to just bring this minus sign down. So it's really just like a positive 4 times 2r. So positive times a positive 2 gives us 8 r's, and again, just attach that variable with it. Then I'm just going to bring everything else down that I didn't use or didn't distribute to, so 8r. Because notice if I wouldn't have this plus sign, it would just be like 8r12. And you'd be like, well, what am I doing between those two things? And I feel like those are two different terms. So always make sure to bring down that plus sign. Then I'm going to combine my like terms. So 8r, right there, a positive 8r. And then we have a negative or minus 8r. So if I had 8r's and I'm taking 8r's away, it's like I have 0 r's, but that's silly to even write that. So we're just going to go ahead and cross them out because I'm not using them at all. The last thing I'm going to do is just combine these two things. So a positive 12 and a positive 1 gives us a positive 13 as our final answer. Alrighty, and the last one we have before you are going to try is number 10. So I have 9 plus 4c minus, and then I just have that those parentheses, right? So I'm actually going to distribute this negative, but we talked about this in 5.1. I have to include that negative 1. I'm going to put a 1 in there because that's actually what I'm distributing is this negative 1 to both terms. So negative 1 times 3c gives us negative 3c. And then negative 1 times a positive 3, or you can bring down that plus sign. Negative 1 times 3 is a negative 3. And then again, we see both a plus and a minus right next to each other. Kind of unnecessary, so I'm going to go ahead and get rid of both of them, and I'm just going to have that minus sign. So then I bring everything else down, 9 plus 4c, and then I just combine my like terms. So I see a 4c and a negative 3c. Notice I went to the variables first because I want to deal with my constants last. So 4c's, I take away 3c's. I now just have 1c. And then I'm going to combine my positive 9 and my negative 3. So 9 take away 3 is a positive 6. And this is actually my final answer, but even better than 1c would just be to write just c. Because if I have 1c or if I have c, they're both essentially the exact same thing. Alright, so now I want you to pause the video and I want you to work out these 3 you-try problems and then push play when you are finished. Alrighty, so I know that this is already kind of a long video, but please go ahead and write a check mark right by those words you try if you are listening right now. So you try, I need a check mark somewhere over by those words, please. The number 11, we have 3n plus 6 as our final answer. And then for number 12, I have 3m plus 13. And then my last answer, I have a negative 8x. So notice that I've kind of shown a little work where you're distributing what it is that you're distributing. Once you distribute kind of all of our terms laid out, and then I went ahead and simplified them. So make sure that all of your notes match up with mine, and good luck on your problems tomorrow.